Let's do binary search next. Given an array of integers, which is sorted in ascending order, and an integer target, write a function to search the array for the target. If the target exists, return its index, otherwise return -1. And then they give us a target runtime of logarithmic. So instead of trying to compete with the thousands and thousands of excellent resources out there that go into excruciating detail about how binary search works, I'm going to talk about a little bit of the big picture and then show you a library I think is particularly important. So binary search is kind of the quintessential divide and conquer algorithm. And then in the real world, when you use it, it's usually going to be with some little variations. So this problem is asking for the classic vanilla unchanged, look for an exact match or return an error. But you'll also often need variations where you need like maybe the first, if there's multiple of them, which one do you take? Well, this would ask for any, but do you want the first one or the last one? Would you be okay with something like equal to or greater than, or do you want to find like the closest of, in either direction, or do you want like something lower than? Like little variations. Anyway, so the C++ library that I want to show you is called lower bound. Lower bound. And it takes, your beginning and ending iterators, so nums begin, nums end, and your target value. And it's going to return, it returns an iterator, so in this case it would be a vector of integers iterator. That's what it returns. And if no match equal to or greater than the target is found, it'll return this ending iterator, which points to 1 past the end of the array. So I'll talk about the documentation a bit. It returns something, the first element that does not compare less than. So the first thing that's equal to or greater than. And similarly, you have this upper bound function that points to the first thing that is strictly greater. So equal to or greater versus strictly greater. And they use the same example in both. So if you have a sorted array input, lower bound, if your target is 20, will return this 20 here. And upper bound will return this 30 here because it's the first item greater than 20. So if they're both okay with things that are greater, neither will return anything less. So if you want to say find the last element of 20, so instead of this you wanted this, you'd want to do like upper bound -1. Little variations like that. So you can use these two in combination to get quite a bit done. And that's about it. Maybe we'll keep the video short today. So it's going to return an iterator. So first we want to check, we can't access this without it throwing an error. So first one is, we want to see if that's the result we got. Iterator equals, if it's, okay, so if it's not equal to the ending, so then if that's not equal to the ending, we can check it. It equals target. Then we want to return the difference. So we have an iterator, we can do iterator arithmetic and get back our index. So it's minus numstop again. Otherwise, we'll return our error code. And that's pretty much it. It uses binary search under the hood, so the runtime is going to be logarithmic, and the space complexity is going to be constant. There's no need to copy it. It's going to do it iteratively instead of recursively. But either way, logarithmic time, constant space. It's a library call. So a friend of mine who's since gone to work for Google and offered to do some practice interviews with me, one of the tips he gave me is he does like to see, instead of using, say, auto, which is, it would run perfectly fine, they do kind of like to see you write out what it resolves to, mainly to make sure that you actually know what it resolves to and you're not using auto as a crutch. Sometimes you can have pretty crazy data types, and in those cases, I think it's probably okay to use auto, mainly for the sake of time. You can talk a little bit about what it resolves to. So for example, if you're writing a lambda function, those can be kind of a nasty data type to write out. For this, it's short enough. Anyway, so that's all we needed to say. I think this is pretty important. It's essential. This is one of the ones that I think is worth memorizing if you work a lot in C++. Yeah, that's all I'll say about that. So let's go ahead and submit and mark it off. So binary search. Thanks, guys.